All right, well, I'm delighted to be back at the Cosmosphere. This is kind of a tough time for me. I'm not going to lie to you. I've been on this beautiful mission to Saturn, Cassini, for 20 years. I joined in April of '97, 6 months before launch. So I'm in, the 5 stages of grief. I'm very comfortably in stage 1, denial. My spacecraft's not crashing into Saturn in 27 short days. This is going to go forever, right? But it's going to be tough to say goodbye. They brought a grief counselor into JPL. It's every Monday, 1 to 4. Now there's a counselor available for us to talk because we anthropomorphize these robots. They have personalities and quirks, and you get attached to them like a family member. So we're going to have to say goodbye in 27 short days as we come crashing into Saturn's atmosphere and vaporizing. Becoming part of Saturn for all eternity, a real ashes to ashes and dust to dust story. But before, maybe I'll get through stage 2 today. Anger, why are we doing this to my beautiful baby? Before that, maybe we can cover 20 years and what a glorious, incredible mission it's been. This is some of our science highlights over 2 decades. Some things to point out. We have gaps in the rings. We knew about that from the Earth. By the way, I love my 450 nanometer laser pointer from China. So it might even be legal. It may not even hurt your eyes like the Eclipse will. We'll see. It's a 5 milliwatt laser. Should be okay. So this is a gap in the rings and some material in the gaps. Some interesting moons. Titan, a moon of Saturn larger than the planet Mercury, has a thick atmosphere, thicker than the Earth. So we're going to talk a lot about Titan. That's a view from the Titan surface. We have a view of Saturn you'd never get from the Earth because the sun's coming from the right side, casting a shadow. Saturn itself is casting a shadow on its rings, a view you would never get. This is 900 million miles from Earth. Really nice shot there. Iapetus, a moon, one side is dark as charcoal, the other side is as white as snow. We're not sure why. Before we got there with Cassini, we didn't even know if it was a dark moon with white stuff on it or a white moon with dark stuff on it. So we were profoundly ignorant, even though we've been to these planets before with the Voyager mission, the mission that inspired me all these years ago to come work at JPL. False color in the rings here, showing different temperature. This is from our UVIS instrument, ultraviolet spectrometer. Up in the upper right, this may be our favorite moon. It's hard to pick favorites like children, but Enceladus is a tiny ice ball 300 miles across, that should be, by all rights, be geologically dead, boring, unchanged in the 4.5 billion years since the solar system formed. It's not. It has a lack of craters. The South Pole is 180 degrees Fahrenheit, hotter than the equator. That's no less surprising than if you flew by the Earth and the poles were 180 degrees hotter than the equator. And it actually has active water geysers. Ice volcanoes, the press dubbed cold faithfuls, and they blast ice crystals out from the South Pole of Enceladus, forming Saturn's E-ring. So the big mystery is why should this tiny moon that should be boring and dead geologically has an internal heat source? Something's warming it up and allowing it to erupt ice volcanoes, forming Saturn's ring. One of Cassini's many discoveries through the years. Next slide, please. Well, where'd the name come from? We tend to, of late, we've named, my first mission was Galileo, a Jupiter orbiter back in the 90s. And everyone knows who Galileo was, discovered the moons of Jupiter going back and forth night to night, and led him to this great leap of faith that, hey, the sun is the center of the solar system, not the Earth, because clearly here are 4 objects in orbit around Jupiter, not in orbit around the Earth. And then Magellan was a Venus radar mapper. We threw a spacecraft together to send to Venus, enshrouded in clouds. Hopefully, like we won't be in Nebraska on Monday. But you can actually, you can't see through the clouds. You can't see the Venus surface. So we threw together a radar mission that can penetrate the clouds of Venus and map the surface for the first time. We literally threw that spacecraft together as spare parts. We stripped the high-gain antenna off the Voyager spacecraft model at the Air and Space Museum in DC, threw it on a spacecraft, launched it to Venus, and got there. So that was named after Magellan because he was the first to circumnavigate the globe, Earth. So this would be the first global mapping of Venus below the cloud tops. So in that same theme of honoring explorers and scientists, we named the mission here Cassini and Huygens. If there's any Dutch in the room, I apologize. My Dutch pronunciation really stinks, but it's like Huygens or something, but we Americanize it and call it Huygens. Now, Huygens discovered Titan, this largest moon of Saturn, and also the nature of the rings. Galileo's telescope could see a bulge here and a bulge here, kind of like me, just love handles on the side of Saturn. It took a Huygens better telescope to tell the true nature that these were rings around Saturn. Now, Giovanni Domenico Cassini, or John Dominique Cassini, he's French-Italian, pick your language. He's the gentleman who discovered 5 moons of Saturn, plus the pencil-thin gap in the rings that you can actually see even with a modest telescope, this little gap right here, called Cassini's division. Now, I wonder if has anyone in the room heard the last name Cassini other than the spacecraft or the division in Saturn's rings or the astronomer? It is a famous last name outside of the world of space science, but it's kind of an old reference. Anyone heard that name before? Fashion, I heard it. Yes, Oleg Cassini was a French fashion designer, and he was big in the 90s when we were launching. So he saw the name Cassini. His people were rather steamed. They called up JPL. How dare you use my name on your spacecraft? I'll sue your pants off, and like, well, actually, pal, get a grip of yourself. It's Jean-Dominique Cassini, French-Italian astronomer. He's like, oh, never mind then. But, for a year, the Cassini T-shirts don't have the word Cassini print on them. They're collector's items now, but we're deathly afraid of litigation because of the last name thing. So now find them if you can, those Cassini T-shirts around launch. So anyway, that's where the name came from. Next slide, please. So this is kind of a call out in the back here. I won't spend too much time here. This is more of a science talk than an engineering talk. But this is not your father's spacecraft. My dad's here today. I'm very happy he came up from Wichita. It's nice. So this is not your father's Oldsmobile, as they say. This is the biggest planetary mission ever built. So it's about 26 feet tall, weighs 7 tons, and over 3 or 4 tons of that is propellant. It's about like a short school bus up on its side, 13 feet across antenna, all kinds of body-mounted instruments. There's sniffing instruments, dust, magnetic field detector. All the cameras are here too, infrared, ultraviolet, visible light. We have to turn the whole spacecraft when we want to take a picture. So the spacecraft, we have people on board. They're like kindergarten teachers helping the science instruments learn to share with each other. No, you have to share with your neighbor. They need some observing time too. Share your toys. So we work through that process a lot. I'm the head propulsion engineer on the mission. I've been working propulsion at JPL my whole career. Worked for an old Caltech guy that worked on the Apollo F1 engine, the Saturn V rocket first stage. So I picked his brain as much as I could till he retired, and then took over as the lead propulsion engineer in 2002. Later, I found out he actually hadn't retired yet. He worked another 5 years. I thought, that's so magnanimous of him to give me the lead role and help my career. Well, we got to Saturn in 2004 and had all these god-awful review boards to make sure we'd get into orbit. So he basically threw me into the fire, and I had to do all those review boards. So Caltech 1, MIT 0, he knew what he was doing. He threw me to the wolves there. But a good training, and this mission was supposed to be dead in 2008, and here we are in 2017, still talking about Cassini. I can't believe what a great adolescence run that was, to make it to 51 years old and then have to finally figure out what you want to be when you grow up. That's a good run. I'm very happy about that. This is quite a spacecraft. We are 22 feet tall, 13 feet across. I mentioned the mass. There are no solar panels. We sized solar panels for this mission out at Saturn. There's something called the inverse square law. If you're twice as far away, you get 1/4 of the sunlight. And at Saturn's distance 10 times from the sun versus the Earth, you get only 1/100th, 1% of the sunlight. So if we had solar panels on Cassini, you could do it. You'd have 2 solar panels, one on each side, each bigger than a tennis court. That would be a tough mission to launch. So instead of that, we use these beautiful RTGs, radioisotope thermoelectric generators. A nuclear battery uses plutonium-238, and the gentle alpha decay of the plutonium, we use a thermionic converter, and that takes this heat energy, changes it into DC electricity, 30 volts, and it's amazing. No moving parts, and the half-life of plutonium is like 88 years, so they last decades. They're wonderful. They're pretty expensive, and they're radioactive, but other than that, they're fantastic. It's not a reactor, though. But the key here, one feature of JPL spacecraft, they're incredibly power-starved. Look at that total power, 700 watts, half of a hairdryer runs the entire spacecraft. All of the science instruments, the cameras, the heaters, that's incredible to me. We had, good old mid-90s technology when we launched this, so we have a half a gig recorder on board. Ooh, So we store all our data there. Now, we not only had a beautiful orbiting ship, we had a hitchhiking passenger from Europe and this was the Huygens probe here, weighed 320 kilograms, 700 pounds. And they hitched a ride for free on our spacecraft, and we released them after we arrived into Saturn orbit so they could go actually float among the clouds of Titan, this large moon of Saturn, and take data as they're floating down, and actually even survived landing on the surface. So we got some surface data from Titan. Arguably the coolest thing Europe's ever done in space science. Maybe with Rosetta landing on a comet, that was pretty cool too. Although they really didn't land too well. They kind of bounced when they landed. So they tried to fire penetrators and they didn't stick. So they did some bounces and ended up on their side. It's a tough biz, Let's see, next slide, please. So here's our beautiful launch. I'll show some things before we cut to the launch video. We launched on October 15th, 97 on a Titan IV Centaur. And it was a night launch from Florida, and we had this amazing cloud right here, and we literally disappeared in the cloud. So for a few seconds, we thought it died because we just didn't see the spacecraft, and then suddenly it burst forth from the cloud. It wouldn't be denied. Head off on its way to Saturn. Now, in one of the strangest cosmic twists in planetary science, it used all its launch energy to slow down instead of speed up because it's too heavy to get straight out to Saturn. So we use this beautiful technique called gravity assist. So here's the sun, Venus's orbit is about here, Earth's orbit's outside, here's Jupiter's orbit, and Saturn's orbit's way out here. So we launched backwards, if you will, slowed down, went on this path right here, the green path, flew by Venus in February of 1998, stole some energy from Venus, and that put us on this red path. We did a deep space maneuver, hour-and-a-half rocket burn, a good practice for the orbit insertion burn some years later. And that was a plane change maneuver to line up for the next Venus flyby. So we came in and screaming in 99, did a second Venus flyby, and then an Earth flyby in August of 99. Now this technique sounds, if you've had high school physics, many in the room have had physics, we believe in conservation of energy. Doesn't it seem too good to be true? You fly by these planets, you add tens of thousands of miles an hour to your speed. How is energy conserved? Well, energy is always conserved, and don't tell anyone, we slowed the planets down just a little bit when we flew by, including the Earth, including the home planet. So we changed it a couple inches every few 100 million years. It's okay, no environmental impact statement this time. But Earth took one for the team. That was basically like our launch. And then we jetted through the asteroid belt, got out to Jupiter, December of 2000, stole a bit of energy from Jupiter. Then 3.5 years, thanks to good old Kepler, he's cool, he has great stuff, but the problem is when you get high potential energy, you slow down a lot out here. So it took 3.5 years to get from Jupiter to Saturn. So total trip time, 6.7 years, total distance, 2.5 billion miles. The question I always got from the kids was, what's the gas mileage? And I said, well, we only used a few hundred or thousand gallons of propellant in 2.7 billion miles. So if you do that math, move over Prius. We got a good hybrid here. This gives some fantastic mileage, unless you count the launch vehicle, because that uses tons and tons of propellant. If you count the launch vehicle, it's worse than a Hummer. It's really, really bad mileage, to getting off of Earth's gravity well. So shall we, and before I play the launch video, this is probably a good time to talk a bit about the nuclear material on board. Because of that, there was some concern, of course. I can't sit here and lie to you and say we won't have a launch accident. We know that's not true. 1 or 2% of the time, historically, for any launch vehicle, including the shuttle, you can have a catastrophic accident. So knowing that, what we had to show is that you can't release this plutonium because in dust form, it's carcinogenic and all these kind of things. So that was fun. If you like destructive testing, which I did, I used to melt holes in the street in front of my house. And my poor dad, I was kind of a mad chemist and scientist growing up. But so we did destructive testing on those nuclear batteries, the RTGs. We shot guns in them, we blew them up, we set them on fire. We just couldn't get the plutonium out. So we were very happy and said, now we feel safe for people to take their families down and watch the launch. This was not convincing enough for some folks. So in '89, we had a Galileo launched on the space shuttle with some nuclear material, maybe 24 kilogram or pound, might have been pounds. I don't want to mess up the units. We've done that at JPL before. Anyway, we had a little bit of plutonium on Galileo on the shuttle in '89, and a few protesters down at the Cape trying to block our launch, including taking us to court. They tried to block our launch date in the court. Now, what was nice there is the judge then threw it out, so we could still make our very small launch window, only a few weeks long. In 97, we had many more protesters 8 years later at the Cape. I blame the internet. It formed in the 90s, and they could all find each other and coalesce and descend on Florida there to block our launch. And they again tried to sue us, and we got that case thrown out luckily. But they were a little more bold and aggressive this time. So they came up to the fence, climbed the fence, and then went to chain themselves to the launch pad. The protesters did to block our launch. And that's no problem. Once they cross the fence line, they're trespassing. We can arrest them and carry on with our business. The problem was there's this little sweet 82-year-old grandmother walking up to the fence, and we said, this is bad press. You know, she's going to throw out a hip, you know, catch her support hose or something. Yeah, she's climbing the fence here. What do we do, you know? And someone said, I've got an idea. They went out to the fence with wire cutters, cut a hole in the fence. She goes through then the hole, and then we put cuffs on her and take grandma off to jail. Everyone was happy. So now after that, we showed her first view of Saturn in a telescope, and she became a big fan of Cassini and all that. But amazing what sometimes you got to think outside the box to get through these hurdles to launch. Another gentleman did make it over the fence in the middle of the night and got to the launch pad. I think a guard might have dozed off or something. So he picks up the gantry phone out at the launch pad site, says, I'm at the pad, what are you gonna do about it? You know? And someone at the other end thought carefully and said, nothing, it's gonna get awful hot out there though. So he ran down the stairs, jumped the fence, never saw him again. So anyway, we had to get through these hurdles to get to this moment, October 15th, 1997. Let's relive launch on the Titan IV Centaur. I don't think we have any audio on this one, so I'll just narrate a little bit. Beautiful launch. Night launches are the best. And watch us disappear into this cloud. And it was scary, I have to say. You're not used to your launch vehicle just completely disappearing like that. But it wouldn't be denied. It had a date with destiny out at the ring planet some 7 years later. So we were on our way, one hurdle down, a million to go to get out to Saturn. Let's see. Yeah, it's about done. I'll let it play to the end. Okay, so great AV work. Thank you very much. So what's our next slide? Okay, so now you can't keep a good scientist down. So we keep telling the scientists this is an engineering mission until we get to Saturn. We need to make sure we get there and all that. But yeah, but we got to calibrate the cameras on a known target like Jupiter. And well, that's a good argument. We can't, oh, goody. So here we go, and how embarrassing for Galileo. Galileo was out there 13, 14 years at Jupiter, but we had a better camera, of course. So we were able to get better pictures of Jupiter than Galileo did and took this gorgeous shot of Jupiter here, gas giant, biggest by far planet in the solar system. The Great Red Spot, a hurricane, been raging at least 300 years, 2 or 3 times the size of the Earth. The moon Io casting its shadow from the sun on the surface. I believe that's another moon that might be, that may still be Io. Io's 10 or 100 times more volcanically active than the entire Earth. So this is the first time they found volcanoes on another world. It's a melted interior, 3,000 degrees Fahrenheit lavas. Earth hasn't seen that kind of lava in billions of years. Sulfur dioxide volcanoes. Now, people familiar with sulfur dioxide, unfortunately, are probably middle school teachers because that's what's in a stink bomb. The little things they set off and the entire school smells like a giant rotten egg. So this would be a rather stinky moon. Jupiter's radiation would kill you in a few minutes without a spacesuit. So we didn't dally too long. We just stole a little energy from Jupiter and went on our way out to Saturn. Next slide, please. And then as we're approaching, this is so great. We were 2 weeks from Saturn orbit insertion in the summer of 2004, which was my 20th high school reunion. And I didn't like high school these days because of Big Bang Theory, nerds are kind of cool. I was not cool in high school. Nerds got tortured in high school. So this is the best revenge of the nerd job in the universe, to go back to your high school reunions. It's so fun. So I just love it. And then, most people were showing their baby pictures. I was showing moon pictures at the reunion. But this is our best picture of Phoebe, an interloper, formed in the outer solar system, got captured into Saturn orbit backwards. It orbits Saturn in the wrong direction, so we know it didn't form at Saturn. That's the best picture we had of Phoebe from Voyager from years ago. So we picked our arrival to fly right by it. So this is the best picture before. Let's see how Cassini improved the view. Next slide, please. Absolutely amazing. So this is a tiny rocky ice ball. There is frozen carbon dioxide, dry ice up in these permanently shadowed, or those aren't shadowed craters, but They sublimate, there's landslides, it's a dark material. We now know Iapetus, the black and white cookie moon, is an icy white moon with dark stuff from Phoebe, this dark, crazy interloper from the outer solar system. So that was a pretty good omen for what was to come 2 weeks later. Next slide, please. So here we are, the night of June 30th, 2004. And I was doubly nervous this night. I was the head propulsion engineer by then. We had one chance we're flying from left to right backwards, and we have to slam on the brakes, or it's Voyager 3, complete mission failure. So we had to fire the engine for 96 minutes and capture it, slow down and capture into Saturn's orbit. Not only, I was doubly nervous because not only did I have that pressure as a propulsion engineer, I also did the live color commentary on NASA TV. So I had to make an hour-and-a-half rocket burn interesting on live TV. That's not so easy. It's like watching the eclipse in real time, right? The hour and a half. And so I did my best, and the most important thing, it worked, and everything went quite well there. Now, I worked Curiosity, which I think is we'll hear a little about it on the next talk. But I also worked Spirit and Opportunity, which were the first Mars rovers back in, they launched in the summer of 2003 and landed in 2004. It was a little part-time job while I was working Cassini. I had a very enviable role on that mission because if it was successful, I could claim excessive credit, on the Eagle, Wichita Eagle, I did the whole thing myself, right? Whereas if I fail, I just say, we were really rooting for you out at Saturn. So sorry you failed and crashed on Mars. So, the perfect situation there, excessive credit or total denial. It turned out to be the excessive credit thing. We went 2 for 2 with those Mars rovers in January of 2004. The first one landed Spirit January 3rd. The second one, a twin, was coming in 3 weeks later, January 24th of 2004. So a couple politicians decided to come to JPL for the landing. They had nothing to do with our success, but how they like to ride a winning design, be on camera, be associated with something that'll be a win for America. So Al Gore showed up, former vice president, as did our California governor as of January 2004. Anyone remember who that was? Schwarzenegger, I heard it. So Jay Leno's joke, he said, all the robots came to JPL for the landing because those guys are kind of stiff and uncomfortable on camera. I love that joke. I thought it was really funny. Of course, they warned us. They said, no photographs, no autographs, leave these guys alone. They went in and out. Now, I collect photos with celebrities. It's a very hickish thing to do, I know. But I knew I didn't dare try a picture. I'd get fired for that. But I want to meet these guys. So I met Al Gore briefly in our main museum. But the Terminator, that's the prize. How am I going to meet Arnie? So we had these long rows in mission control. And Arnie walked up and down them very fast. We're all sitting at our desks or at the terminals. I said, you know what I'll do? I'll just stand up and block his path like this. He can't get by without saying hello. He didn't really know how to react then. Congratulations to you and your team. You're doing marvelous work here at JPL. So, accent's not so great, but I was excited. I met the Terminator, I recreated the moment. I shook my friend's hands, did the accent. Then the phone rings, propulsion here. It's your mother. Hey, Mom, you're calling. Congratulations. No, my friend said, I heard, what are you doing there? It's like, well, I saw your little, I said, well, let me back up here. I said, you're calling to congratulate? No, I'm calling to see if you still have a job, pal, or if I need to give up my sewing room, which used to be your bedroom, when you have to resign in disgrace. It's like, what are you talking about? We land on Mars. She said, well, I saw your little stunt, standing up, meeting the governor, but then imitating his accent, telling your friends. I said, how did you hear this? You're in Wichita, you're 1,500 miles away. She said, my dear, CNN, there's a live mic right here, and a live mic right here. So there's a lot of youngsters in the room. That's a cautionary tale. Watch those live mics. They're not just taking down politicians. They can take down rocket scientists too. So be very careful with that. Now, if Cassini had any inkling of my shenanigans with the live mics, they would have never let me near one for orbit insertion. But luckily, Mars and Saturn weren't talking to each other, so I still got that incredible moment there. Next slide, please. Okay, now once we're there, and we're going to play this pedal movie after I'm done, we had a 4-year prime mission, summer of 2004 to summer of 2008. 75 orbits, that's incredible. See, the Voyagers had been to Saturn before, but at the Kodak moment, they had 3 days of Kodak moments. You're going by at 50,000 miles an hour, then you're on to the next destination. The beauty of a Galileo or a Cassini is the first time you get an orbiter at a gas giant planet, and there are dozens and dozens of moons. So you can watch things evolve over time. You can be reactive and change the science goals and what we learn, and we did that. So 45 flybys of Titan. Not only because Titan's interesting, but Titan's the big bully of the moons there, so it's the only one whose gravity we can use in this gravity assist technique to shape the next orbit to get to a different part of Titan or to get to an icy moon or even study Saturn from above like a bullseye. So we see the North Pole and the rings. So that was incredible. And even in those 4 years, summer of 2004 to summer of 2008, we flew by 8. We had 8 targeted icy moon flybys, some of Enceladus, some of Rhea. Saturn's got 64 moons, I think, at latest count. Here is Saturn, the rings. The rings are named in order of discovery, A through G, and not in order from the planet. So if you go out from the planet, I think it's D, C, B, A. I might get it wrong, but any musicians in the crowd? So A through G, of course, is the scale, notes of the scale. So composers have used this and written pieces based on that pattern of A through G, as going in order from Saturn out, because it's not in scale order. So that's a pretty clever idea. The rings themselves are icy particles from dust size up to mountain size, billions of them in their own individual orbits around Saturn. But there's a lot of detail in the rings. Of course, we want to understand that. There's this E ring that we didn't know the source of. Now we do. Enceladus is belching forth icy material to form the E ring. Here's the size of the moons in comparison. There's Titan, bigger than the planet Mercury, and then the other icy moons are smaller than our moon, down to very small rock size. We had 5 co-equal science objectives. Each is worth 20% of the mission success, if you will. That's Titan. Titan gets its own 20%, even though it's just one of 64 moons, because I mentioned the thick atmosphere, thicker nitrogen atmosphere than Earth's. What I didn't mention before is there's liquid on the surface. It's 300 degrees below zero. So water is brick hard ice, but methane and ethane, natural gas, the same thing in your stove, is liquid at that temperature. So amazingly, on this moon, 900 million miles from Earth, anything you can think about on Earth due to the fact that we have water as a solid liquid gas, on Titan we have methane as a solid liquid gas. So any process caused by having those 3 phases of matter on Earth, we see at Titan with natural gas at 300 degrees below zero. So I'm talking things like oceans, seas, lakes, rivers, fog, mist, lightning, clouds, ruined eclipses, mist, fog, you name it. So isn't that amazing? At 300 below, with natural gas, we see the same phenomena we see on planet Earth. And Voyager couldn't see through the surface. It's like the Venus thing. So we sent a radar mapper. We can map and penetrate the clouds of Titan. And of course, then the Huygens can measure from the atmosphere and then even from the surface. So it really was a huge science objective. Saturn itself, what do the storms have to tell us in the atmosphere? It's not as dynamic as Jupiter, but there's still some cool things happening in the atmosphere. The rings, how old are they? How heavy are they? When did they form? What's their interior structure? Why do they look the way they do? The icy satellites that ended up being a lot more interesting than we thought, especially Enceladus, the one with the active water geysers. And then finally, the magnetosphere. Saturn has a big magnetic field. It's smaller than Jupiter, is much smaller than the sun's, but bigger than Earth. So we want to understand that as we dip in and out of it over the course of our mission. So let's back out of the slideshow now and then show the pedal plot. And this is going to go pretty fast. But these are our first 4 years, the 75 orbits. They're not all in the equatorial plane. We'll see that. We cranked up the inclination so we could fly not only over, here we go. So we arrived. These are all kind of in the plane. Now look, we're cranking the orbit up. We're going over the poles. That was a busy 4 years there. Let's play that again. That's just too cool. So that kept me busy from summer of 04 to summer of 08. And for each orbit, there's 3 propulsive burns. So, 75 orbits, there's a couple hundred burns there over the 4 years. They're all ellipses. Good old Kepler is still in charge, but we could really sample the system around Saturn that way. Different latitudes, different longitudes, flying by the moons. And by the time we were done with orbit insertion, we were 2/3 empty. By the time the prime mission was done, I'm an optimist. I'll say we were 10% full on the gas tank, where pessimists will remind me you're 90% empty, which is true. And here's the other problem. There is no gas gauge on Cassini. I'm the gas gauge as the lead propulsion engineer. So in your car, your gas gauge works. It's a fill sensor. It measures the height of a liquid in a tank in a 1G environment in Earth's gravity. That doesn't work in a spacecraft because the propellant floats around and clings to the walls and it's surface tension that wicks it out. So how do you measure a liquid level in a tank like that? It's a real challenge. And if you think things were bad then in 2008, wait for what's coming next. So let's talk about some of the things we found in the prime mission. Titan, huge, bigger than Mercury. Here we go, dense atmosphere, claims route haze. So it's mostly nitrogen. There's no oxygen there. But there's hydrocarbons. There are organic molecules that rain down like manna from heaven, as Carl Sagan used to say. So it's hard to think life would start at 300 below, but it's got the right ingredients and a subsurface liquid water ocean as well. Unbelievable. Let's go to the next one. Look at some pictures and talk about the. So here's the Huygens mission and probe. So we brought it along. It has no propulsion of its own. So we released some pyrotechnic bolts and springs gently pushed it away. And now, JPL, Isaac Newton runs the show. We're slaves to his laws of orbital mechanics. So when it says something has to happen, we're like, okay, when and where and what holiday will you be ruining this year? So this was Christmas Eve of 2004. That's when the stars aligned that we had to release Huygens. Huygens then parachuted through the Titan atmosphere and landed on the surface. And actually, Vegas, they'll bet on anything. The odds in Vegas were 40% that it landed liquid and 60% that it landed in a solid. So people were betting on whether it would land in solid or liquid. By the way, if it landed in an ethane or methane sea, it was meant to float for a few minutes and could actually measure, the liquid before it glug, glug, glug down to the bottom. So that was pretty clever. We ended up landing in kind of a wet sand. It was dry, but we were much warmer than the surface, so we caused some methane to escape. Who among us hasn't done that? So, it was quite the landing there on January 14th, 2005. So it flew on its own for a few weeks from the Christmas Eve, all kinds of parachutes deploying. I mean, it's tricky because we really don't know the atmosphere that well. So you got to over-design and be reactive. So what a great success for Europe. And we were happy to ferry that passenger along the way. So if we can back out there, I'll show you the probe release. And then I think it covers, what happens a little bit in the atmosphere, our third video. These are all animations for the most part. Okay, so we're flying around Christmas Eve. There we did. We fired the bolts, give it a little spin for stability, and it flies on its own, no propulsion. Now, the scary thing then, to do that, we had to put the whole mothership on a Titan impact trajectory, right? So then what if you lose control of your spacecraft? It's going to just follow the probe in and crash. So luckily, we did a burn right after that. Dad, that's why I missed Christmas that year, but I had to do that burn, to make sure that this would happen, that we'd hit the atmosphere. With Huygens, we prop out a little drogue chute to slow down, release the heat shield, and then this starts spinning around and it's taking data, sniffing the atmosphere. Another chute comes out. Now, the atmosphere is actually so thick, we had to get rid of a bigger chute and then come down on a smaller chute later, or it would still have been floating by the time it couldn't talk straight to Earth. So we had to fly overhead in a choreographed ballet to catch that data and then relay it to Earth. And in fact, if we hadn't changed parachutes, it wouldn't have hit the ground yet by the time the mothership flew over. So it's bringing in, sniffing, sending signals to the mothership, measuring pressure, temperature, chemistry, wind speed. What else? Let's see. Looking for lightning. It has a camera. It's taking pictures on the way down. I'm going to show that next. So it's just gently floating down. Had a searchlight, to kind of light up its surroundings after it landed because it's a real hazy sky there. So this was mid-January 2015, and by gum, it worked. That was pretty nice. So let's go back and see what Huygens found. So this, I should have just had you, I'm sorry, I should have had you stay with the movies, I forgot. So this is a still at 150 kilometers, about 90 miles altitude from the surface. So if we go back to the movies, what we'll do now is play the movie. And of course, it's randomly spinning, but this is what the camera saw during the Huygens descent. So what was sad is we saw nothing for a long time. The haze was really thick. We just can't see anything on the surface. And then suddenly, we burst through and then start seeing real surface details here. There we go. So you see things look like dried riverbeds up there? So we'll talk about that when we get a still. So we're getting closer and closer to the surface. Scientists were thrilled. We were so tickled that it was working. And there, that last one, I don't think we'll need to show it because I think I've got that surely as a still image. Let's go back to the PowerPoint. So the next slide should be, okay, these are from the movie. So the first thing the press did is said, you faked the whole thing. This isn't Titan, this is Southern California. There's Malibu and LAX is over here, and here's the dried riverbeds because there's a drought in LA just like on Titan. So, it did look a lot like LA. I had to kind of give them that. But no, this is Titan, 900 million miles away. Look at those dried tributaries where methane rivers flowed down to methane lakes and seas. And in fact, we landed in this dry, sandy beach area. It had a little bit of methane, but it was currently in a bit of a methane drought. So we didn't land in liquid, but it was kind of moist sand. And next slide, please. This is the surface view. So not the most exciting coloring, because of this orange haze, but wow, we're so far from Earth. There's the horizon. Now, look at these pebbles. These are actually water ice rocks that are hard as rock at 300 below. Does nature make jagged rocks or smooth rocks generally? What do you think? Jagged, I heard it. Yeah, so why are these smooth? Erosion. Yeah, so they tumbled down these rivers and wore off the rough edges. So this is proof of a flowing liquid environment, at least in the past, at this location on Titan. What a terrific thing. Now, we knew we'd hit the public zeitgeist when we started appearing in your supermarket checkout line, the pictures of Titan. Next slide, please. So here we were. We had these strange cats on the left. Now, those weren't so bad. I could live with this. This dude actually scared me, though. He's very creepy looking. And I had a little nightmare about him until I remembered that these rocks were 1 inch across each. So he's a pocket-sized monster. But we knew we had arrived there in January of 2005. Okay, next slide, please. So then, as I mentioned, Titan is our cousin in a deep freeze, not so far away from the Earth. If you took Earth out there and replaced water with methane, this is what we'd see. So we see clouds, streaks, drainage channels, river channels, lakes at the North Pole. Not many craters. Objects tend to burn up in the atmosphere. We see wind-driven patterns, hydrocarbon dunes. So there's sand dunes, but the sand's made of hydrocarbon. It'd be like a solid fuel, almost like a paraffin wax. So it's just a crazy place. Again, with a subsurface water ocean. That's nuts too. Next slide, please. Okay, so let's talk about the atmosphere. What kind of chemicals are there? Well, Venus has got some oxygen, hydrogen, nitrogen, a nice little mix, same as Mars. Earth is pretty much nitrogen, hydrogen, and they're ions, they're charged species. Jupiter, it's hydrogen and helium all the time. That makes up 99% of the atmosphere. But look at Titan. There are more organic molecules there than in Walter White's chem lab. So, I mean, this is Breaking Bad on Titan there. That is unbelievable. So these are the right ingredients to start forming chain molecules, amino acids. Doesn't mean there's life on Titan, especially since it's so cold, but boy, the building blocks are there. So that's an incredibly exciting place. So we use INM's ion and neutral mass spectrometer. I'll talk about it a little later because it's the star of the show for our last minute of life in 27 short days. Next slide, please. Okay, so if that wasn't cool enough, then Enceladus, which Voyager knew had something weird going on, there's a real lack of craters near the South Pole. There's these blue things called tiger stripes. There's craters in mid-latitudes, but it's a smooth, pretty billiard ball smooth, lack of craters, geologically active. We knew it sat within Saturn's E-ring, but we didn't know why or what could be happening there. Well, so we did this flyby within 100 miles. That was incredible. Next slide, please. Then we started taking its temperature. That's when things got shocking. The South Pole being way hotter than the equator. This is what you'd expect the temperatures to look like just from where the sun falls. But the South Pole was much, much hotter. And in fact, the heat were located, they peaked on these tiger stripes. So this is kind of hot, but where the tiger stripes are, it's really hot. So some source of internal heat is coming up through those tiger stripes. Next slide, please. So the imaging scientist said, can you take an eclipse photo when everything's in the dark? And we're like, you won't say anything. We're like, well, you're probably right, but just humor us. Let's try it. Let's get the sun behind it and see what happens. So we took this shot, and lo and behold, the discovery of erupting geysers, water ice geysers at the South Pole of Enceladus. In fact, there's the movie. It's auto-playing. That's great. And there's a false color stretching just to show. So not only did we then understand why there's a lack of craters, we could understand the source of Saturn's E-ring. That all made sense. The problem was this moon's too small. It should have cooled off and be geologically dead. It should not be geologically active. What? That's still a mystery why it's geologically active. Although now we know it has a global subsurface water ocean with cracks into the surface, and in fact has hydrothermal vents at the bottom of those oceans. The very place where life may have started on Earth could be on this moon. And remember that, because that discovery is what sealed Cassini's fate, and then why we have to end the mission as we are. Next slide, please. Okay, the rings themselves. Now, they look cool in a telescope, but boy, when you get close, it just goes crazy. We see all these incredible density waves, spiral density waves. This is, I think, is cool. We're actually learning how galaxies work, the spiral arms of galaxies, because they have these same wave and ring structures like Saturn's rings when we look at it close up. So this local environment where we're sitting and we can look at things close up has helped people that are trying to understand how galaxies form and spiral arms and things like that. I think that's so cool. It's just beautiful too. Next slide, please. So Iapetus, we had one shot at this, the black and white cookie moon. So that was our best kind of shots from Voyager. Next slide, please. And then Cassini got close. Well, it surprised us with a belly band, this really weird, it looks like a walnut or maybe a propellant tank, and that's the weld on the equator. And it's a very strange looking world. Next slide, please. So if you'd stretch that to the Earth, this belly band would be 20 times the size of Mount Everest and more than twice as long as the Andes. This is quite a mountain range. Next slide, please. Okay, there's the system of moons again from Titan on out. The rings, there's Enceladus in the middle of the E-ring itself. So we got to 2008. We had some resources left. They said, what would you like to do? We said, let's do a 2-year extended mission at full funding if we can get it funded. And we call that the Equinox mission because we arrived in northern winter, and this would take us through spring. And spring on Saturn is really cool. By the way, so the Saturn year is 29 years long. So each season is 7 years long, 7 years of spring, summer, fall, and winter. So that first 4 years took us mostly through from winter to spring. But 2009 was spring. And what happens then is the rings disappear as seen from the Earth and from the sun. So things get really weird there. When the rings disappear, you can search for moons and look at shadows, long shadows on the rings, like you see long shadows on Earth at sunset and sunrise. Next slide, please. I hope I have some photos of that. I may not, because this is my short version of the slideshow. So before I play this movie, I'll just say we learned a lot in those 2 years about Saturn. We had some resources left in 2010. Now, by this time, we had 5% of the propellant left. Again, optimist. We have 5% left, plus or minus 2%. So that's a little scary. And we asked the scientists, what do you want to do? And they never agree on anything. You can't they all have different science objectives. They all agreed. They said, we want to go 7 more years. We said, are you high? And then after that, we're like, wait, we're very suspicious. You never agree on anything. Why do you all want to go 7 more years? They said that's another Saturn season. So we could watch it go from spring to summer. And because going from summer to winter would be like going from winter to summer by a symmetry argument, then basically we can see Saturn through its whole cycle. If we could just find a way to stretch 5% of the propellant and last another 7 years. So that was my challenge and the whole team's. And I think we're gonna make it. We're 27 days away. So those 7 years, I don't have a lot of slides about them, but we just continued with the Titan flybys. We got up to 127 Titan flybys, not the 45 mentioned in the first 4 years. We did 26 Enceladus flybys total, a bunch of the little moons. We cranked the orbit back up to be over the poles again. That was incredible. And starting last November, things got really interesting. The first thing that we did were called the F-ring orbits, or the ring grazing orbits. So we're in a nearly polar orbit around Saturn, and we moved in the closest approach when it went through Saturn's ring plane to be very close to Saturn's kinky outer braided F-ring. And this is an old picture of the F-ring. There's a moon called Prometheus that dips into the F-ring and steals, and how appropriate, because Prometheus stole fire from the gods in mythology. So if we can go to that movie, we'll watch Prometheus do a little bit of its gravitational mischief as it pops into the F-ring and steals some material and leaves a wake in its path. So there we go. Now we'll be in the shadow quickly, so it'll disappear. Don't fret. And then when we come back out, look what it's done to the ring there. It's stealing material off. So that's just great. Let's play that again. Oh, you little scamp. So you got to watch these moons. We have shepherding moons. This is really cool too. So there's these two moons that orbit, one on the outside of the F ring and the other on the inside. And of course, the one on the inside goes faster, Newton's laws again. But as it overtakes the one on the outside, they actually switch places. So that's crazy. They cross the F ring and trade places, and they're shepherding those F ring particles in between. That's really nuts. Yeah, I think let's go on to the slides. I'm running out of time a little bit. Okay, then when we get over the poles, what? There's a polar hexagon. Nature doesn't like sharp corners, and I'll grant you it's a little bit of a rounded corner. But look at that crazy hexagon storm at the North Pole. We wish it were a pentagon. Then we could get military funding in perpetuity. It'd be awesome. But nature doesn't work that way. It seems to like these six-sided figures. We've seen similar things on Earth in the March, sometimes in the spring in the northern hemisphere up near the pole. And it's a standing wave kind of phenomenon. This wave sets up. Right in the middle, though, this is a hurricane that's just huge. It's been raging. And we've seen it like we've never seen it before, these last sets of orbits. So from November last year through April, we did these polar orbits crossing right outside the F ring. And if that's not crazy enough, we saved the best for last, riskiest too, in what's called the proximal orbits. Next slide, please. Oh, well, first we got to get through Hyperion, the loofah sponge. This makes me want to take a bath. So that's a weird looking moon. Now, Saturn has a lot of things that it's thrown at us over the years. That was actually in the prime mission. Next slide, please. So dark material in the crater floors. Next slide. So we'll go kind of fast through these. Okay, we love this one. Now, this one's a little freaky because if you remember your timeline, Star Wars came out in 1977, right? So the Death Star was 77, and we had no idea what Mimas looked like until Saturn was visited by Voyager in 80 and 81. And there's Mimas. So that's a little strange. Now here's the TIE fighters. TIE, another acronym, twin ion engine, but this is not real. We didn't see TIE fighters at Mimas. This is the crater Herschel. Whatever caused that crater, if it had been a little bigger, it would have blown Mimas to smithereens. So that's our Death Star moon. We love it. It's very weird though. Next slide, please. Okay, so now I mentioned from November to April, we did these F ring orbits. Here they are, the ring grazing orbits. So they came down right outside the ring there and took those incredible pictures. And we did a bunch of those, but this very last one we did in April, we flew by Titan, and Titan's gravity nudged us in a place that no spacecraft has ever gone before. I know that's Star Trek instead of Star Wars, but look what it did. It put us on this orbit right here. So for the very first time, we're passing between the rings of Saturn and the planet itself. This is scary. We know there's some dust in there, so we're threading a needle only a few hundred miles thick. If we're too high, we'll crash into the dust. If we're too low, we'll burn up in Saturn's atmosphere. So we aimed right for the middle of it for the first one and made it in April. And in fact, we've done 22 orbits once a week from late April until mid-September. On 9/11, we're going to fly by Titan again. It's already built into the orbit, and Titan will nudge us one last time. And what that does is puts the final orbit, the low point of that final orbit, within Saturn's atmosphere. I'm doing pretty well working through stage 1 of grief here by saying these words out loud. I wore this shirt today. This is the landing. There it is again. I'm back to stage 1. We're not landing. We're crashing. We're vaporizing. Okay, so this is our crash shirt, the royal color. Now I have to a little Kansas connection. Our secretary got a call from someone working on the mission because the people working, they don't let the public get the purple. That's just for the folks on the flight team. So somebody on the flight team called up and said, I just saw the pictures of the shirt. I can't do it. I go to KU. I just can't wear Wildcat colors. So please, you got to make me a blue and red one. No, sorry, that's the deal. So I guess our next speaker's from K-State. So score one for the Wildcats there. We're wearing your royal purple on landing on crash night. So we'll, I'm getting there. I'll get through it. I will find employment. I will find something to do. We'll find a way. So why crash? I haven't covered that yet. believe it or not, there are bacterial spores on the spacecraft. We never thought we had to sterilize these spacecraft, worrying about contaminating other worlds that might have their own life. We're a victim of our own scientific success. So in order so that after we run out of propellant, we don't accidentally crash into Titan or especially Enceladus, we have to burn up, vaporize the spacecraft, clean up our trash. Forgive me, baby, for saying it, but we have to euthanize it. It has to take one for the team. Now, of course, Cassini won't do that, won't go gently into that good night. So it's going to point at the Earth with its antenna. It's going to sniff as it's hitting the atmosphere, but from the top of the atmosphere till we're vaporized or till we've tumbled is less than a minute. But that is 1 minute of precious science data on what Saturn's made of. We can't wait. I know I'm running long here. About done. Next slide. So what did we find in the FERPO orbits and these proximals? Look at there's the polar hexagon again. I'd play that golf shot. That's pretty amazing. The rings, material in the rings, Saturn, but this one's the craziest fall. Look at this moon pan, 20 miles across. Isn't that the craziest? Pick your food stuff, tortellini, ravioli, empanada, fried egg. No matter how you slice it, it makes you hungry when you look at this moon. But it's so weird, it's collected material, and that's a solid object. So next slide. I'm just about done. There's our website, saturn.jpl.nasa.gov. Be sure to check that out. And then there's a, next slide. I think, let's click the bottom one. This is about 3.5 minutes, but it shows what happens from April through, and there is sound on this one, so through the crash.
A lone explorer on a mission to reveal the grandeur of Saturn, its rings and moons. After 20 years in space, NASA's Cassini spacecraft is running out of fuel. And so, to protect moons of Saturn that could have conditions suitable for life, a spectacular end has been planned for this long-lived traveler from Earth.
5, 4, 3, 2, 1, and liftoff of the Cassini spacecraft on a 1,000,000-mile trek to Saturn. We have cleared the tower. Its program is in. The program is in.
In 2004, following a 7-year journey through the solar system, Cassini arrived at Saturn.
The SOI burn attitude or pointing position, and light up the rockets.
The spacecraft carried a passenger, the European Huygens probe, the first human-made object to land on a world in the distant outer solar system.
Huygens arrival on Saturn's moon Titan.
For over a decade, Cassini has shared the wonders of Saturn and its family of icy moons, taking us to astounding worlds where methane rivers run to a methane sea, where jets of ice and gas are blasting material into space from a liquid water ocean that might harbor the ingredients for life. And Saturn, a giant world ruled by raging storms and delicate harmonies of gravity. Now, Cassini has one last daring assignment. Cassini's grand finale is a brand new adventure. 22 dives through the space between Saturn and its rings. As it repeatedly braves this unexplored region, Cassini seeks new insights about the origins of the rings and the nature of the planet's interior, closer to Saturn than ever before. On the final orbit, Cassini will plunge into Saturn, fighting to keep its antenna pointed at Earth as it transmits its farewell. In the skies of Saturn, the journey ends, as Cassini becomes part of the planet itself.
I made it through this time. I'm making progress, okay? And I know I'm just a pinch long, but I forgot to mention the propellant. So as of a few years ago, we were down to 1% of the propellant left, plus or minus 2%. So that is incredibly, so every main engine burn we've done the last few years, including one on my parents' 50th anniversary, I had to miss their anniversary. And I asked Mom, I said, what do you want me to do? She said, we don't want you living here, pal, so you need to stay there. But who'd have thought back in August 8th, 1964, they'd have a kid that would grow up, would be, worrying about running out of propellant on a Saturn orbiter, right? You can't project that kind of thing when you're born. We took to using a JPL tradition called the JPL Lucky Peanuts. The Rangers crash landed into the moon in the 60s, 1964 and 5. And the first 6 Rangers all failed. So they had launch vehicle failures, and then the launch vehicle worked, the spacecraft died. And then both those worked, and the camera died. Then they finally got it. The launch vehicle, and these were just crash landers in the moon, take a picture. So the launch vehicle worked, the spacecraft worked, the camera worked, but then they missed the moon. And that's kind of a big barn of a target to miss. So 0 for 6, they had no fingernails left. Somebody on Ranger 7 brought in some peanuts and had them nervously eating, passed them down the line, then Ranger 7 worked. They're like, So they brought them in for 8, 9, and 10, and then they all worked. And then they forgot the peanuts and crashed again, failed again. And then they had another mission that didn't launch for 40 days. They had weather problems, range, technical problems, and they said, why, we have thought of everything. Why won't this launch? They're like, we missed one thing. They brought in the peanuts and they launched the next day. Now, JPL, we're not superstitious. We're scientists and engineers, but every mission since 65 has had the JPL Lucky Peanuts. It's in our script. So we've usurped that tradition for Cassini for our main engine burns the last 2 years. We've had peanuts at every main engine burn. No problem till last year, our final big burn, March 25th, 2016. And that's Good Friday, and I'm a practicing Catholic. That's a fast day. What do? Do I fast? Do I buck the Lucky Peanut tradition? Maybe I can seek papal dispensation. Francis is a very chill pope. Now he's probably too busy. And eventually I said, if I fail, it's not just me. I take down a whole flight team. It would be selfish. So forgive me, Father, glug, 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 Lucky Peanuts. So my mortal soul took one for the team to have the Lucky Peanuts. And I know I'm perilously late. Can I close with one image? One image, that's it, I promise. Okay, because we lost it already, sorry. Because it ties into our last speaker too. So I promise 1 minute. I started late, just remember that, okay. And can we kill all the lights for this? It'll be, even the ones up front, or is that possible? Maybe not, huh? Not easily, that's okay. Okay, speaking of eclipses, twice in the whole mission, as seen from the spacecraft, the sun was behind Saturn, a Saturn eclipse. We can't point the spacecraft at the sun. But when we knew these moments were here, these Kodak moments, we did a giant exposure, 12-hour exposure, and that's what we saw. And this is not false color. This is what Saturn looked like from backlight after a 12-hour exposure. The rings, diffraction, refraction, show it on this side. Where the rings are bright, the sun's coming through. The E-ring shows up. We discovered a whole new ring when we did this. Not even the best part of the plot. The best part of the plot is, let me try to see it on this screen, because we did it twice and I want to get it right. Okay, got it. So right here, there's this tiny little dot. And it may be a little hard to see, but the good news is you have a lithograph with this and you get to take home in your package. Any guess what that dot is? Earth, that's us, that's all. 7 billion of us right there on 1 pixel. Everybody you've ever known, everyone that has ever lived, everybody you've ever loved or fought with, English. That's where it all happens. We got to protect this beautiful blue marble. Thank you very much for your time.